hatte ein Research-Thema so im Bereich Big Data, also Semantic Web und so ein Zeug war so mein Thema damals. Ich habe uns auch fertig gemacht, alles gut. Ne? Und dann komme ich da an und dann wurde mir gesagt, ja, ich muss so ein Interview machen über dein Forschungsgebiet. Okay, ja, alles klar, machen wir. Und die haben mir eine Minute vor dem Interview gesagt, wer mein Interviewpartner ist. Wenn ich dir direkt mit mir Fragen beantwortet, direkt neben mir, also so wie wir beide gerade einen Meter auseinander und dann wechseln. Also nicht im Sinne von wir sprechen,
I hope that you have a nice day here with us. We don't have here today our students because we are in the end of in the end of the term. They have a lot of exams in this moment, but they will come tomorrow from another place near from here called Apóstoles. If you have time, any time tomorrow, maybe we could pass something together with our students. But in this moment, we have an online transmission of the whole presentation, yes?
Live streaming.
Live streaming, ok. Damos la bienvenida a los docentes, a los estudiantes del Dual Hochschule Baden de Württemberg, ¿sí? From Württemberg. De la carrera de Data Science and Business Informatics, ¿sí? Ciencia de Datos e Informática Empresarial. En este momento vamos a tener la presentación de los profesores que nos acompañan, Denise Pfister y Kai Holschuh.
Únicamente el señor Holschuh.
Bueno, únicamente el señor Holschuh va a dar una presentación y después van a estar Niklas Svicic. Do you can say in the correct way? Siewicz. Okay, Siewicz, Niklas Siewicz, and Louis Klenk with the presentation time series analysis. Okay. Thanks for staying here. After this presentation, we will have the presentation of our teachers and a little presentation from me about our institute. Yes? So take the place here. Thank you.
I don't think I need the microphone. I hope the room will put a streaming, I guess. For streaming?
Tiene que posicionarse enfrente de la cámara, ahí enfrente del escenario se enfoca mejor. Ahí, justamente ahí para el vivo, sí. Está transmitiendo.
Hello, I hope everybody can hear me. Thank you again for inviting us and giving us this opportunity to share a little about who we are and also share with you and get to know who you are. And maybe between our curiosities of information science, Internet of Things, data science, business, and getting along in this world, we can grow. Thank you. A little explanation of our university here. We're going to see it on the slides in a second. Coming to a theater near you. Hey, everything's worth waiting for. Excuse the moment of technical delay. We're working on it. But it's all part of the experiment, please.
This is not physical.
Yeah.
Something will go wrong.
Oh, it's the little gremlin effect. Here we go. We're going to get it on the screen soon. Whoop. Check out. Yeah, okay. But I'm not a stand-up comedian. I'm sorry, I can't make any entertainment. It's not my thing. Although the thing about quiere decir que no puedo moverte durante la presentación. O sea, yo suelo ser una persona que se mueve. Yo no soy practicado.
Escúchame, si apuntamos la cámara ahí, ahí directamente, entonces, total que la apuntamos.
Bueno,
Hacemos así.
la cámara nomás.
No hace falta que mueva.
No, todo lo bueno que sé.
Que apunte para allá. Justo el profesor decía que no le va a apuntar a él, que él no se da que hacer. Ahí.
Ahí le pones la pechera.
Ahí está.
Le pones la pechera. No, por la marcamos porque si no, lo que podemos hacer es. ¿Tiene otra computadora la presentación?
Tengo un stick. Como tiene también la pantalla,
Claudia, ¿nos prestas tu compu? Ahí Claudia tiene una compu y ahí está la presentación.
Y bueno, pero no tiene nuestra presentación. Solo tengo dos de los tres. Sí, pero solo tengo dos de las tres presentaciones. La tercera la tiene él en su laptop directamente recibido por el internet. Sí, lo que el chaval, sí.
Copiarlo al stick ahí.
Editar todo.
Ladies have to stop.
Y esta que se
Ahora sí, pues solo tenemos esas dos presentaciones. La tercera la tiene todavía sobre el... Bueno, y ahora presento desde aquí.
Sí,
Necesito
sí, por favor.
tampoco quiero bloquear la pantalla. Aquí al lado, aquí quiero... ¿Se me ve y se ve la pantalla también?
The place where we come from in Germany, we are very glad to be here, thanks to our international colleague, Professor Sotomayor, at the Universidad Nacional de Misiones. Gracias. UNAM. We share a common interest, but now let me help you get an idea of what we really do and why we're called DHBW, Dual University. What we do is a dual way of mixing studies and working. Let's see here. All right, so we're sited in this corner of Germany. For those who are familiar with Germany, Germany's about 5 times bigger than this, or at least 5 times bigger than this. This is the French border, this is the Swiss border, this is the Rhine River. And in this corner, in this state or province of Germany, this is where our university is anchored. And we have various campuses around this area. We started, as of last week, 50 years ago. Oh, I can point at the things. Oh, thanks for the, always help from the friends. As it is, yes, here we go. Very cool. So here we see all these nice campuses. Why do we have so many campuses? Well, because we want to get close to businesses, and that is really the core game that we play at the Duale Hochschule. We have 32,000 students about in a 3-year program. That means a 6-semester program. It is a bachelor program. That is the general program. We do also have master studies. I will get to that in a second. But our core business is this 3-year program over the last 50 years. And we do it in different faculties. I will get into that in a moment as well. Here you can see some of the other major dimensions of our school: 10,000 lecturers, 2,500 staff members, a large alumni network. And now we're getting really into the core difference. We have corporate partners, and we do have a diverse range of programs. You're going to see well over 100 programs in a second. I'll get to that. But let me already get to the core issue of what makes us the Duale Hochschule. We work intensely with businesses. The fact of the matter is, all our students are already, so to speak, hired by our dual partners to even be eligible to register in our study program. These 9,000 in between dual partners can be large firms, world-renowned firms, ABB, Siemens, BASF, Mercedes, SAP, and so on. Or they can be middle-sized firms, and they can well even be smaller firms. They are firms then that hire these young people, usually out of a pre-university high school system, to then work full-time on a full-time salary basis with all the protection, the labor protection and so on that is accorded that. And then they can, and in order to be able to come to our university, then they get assigned to those type of programs that actually also the job offer, the firm, has decided for them. And again, I will get into how many. There are many programs, but generally in two major schools, that of business, the largest school of interest, and then that of engineering, the second largest. Whoops. Going on in the core matter of what we are doing. Okay, so we trade off. How do we trade off? There are lots of sort of semi-dual programs in the world, and there certainly are in Germany. And you're probably all familiar with being able or needing to work in order to study. It costs money. It costs money just to live while you're being a student and studying. The case, though, is different at our program, the Duale Hochschule, because our students are then full-time employees. How do we catch that happening? It's not that they're working just on weekends or that they're working at night times or online or any of those type of common experiences that you see, and we also well have in Germany. It's that they are spending usually on an exchange of 3-month basis at the employers and then 3 months at the university. And when they are at the university, we instructors, professors, teachers, will be imparting theory-based education, accredited university education at a highest level. We are systems accredited, like top universities. In fact, we are a desirable university, or one of the more desirable universities in the country to be able to enroll in. And at the same time, we mix our curriculum with that which we discuss with our partners, and we change on a regular basis. Not the goals, those have to go according to accreditation standards, but according to content, which, according to technology, for example, like in the area of data science, which our group here represents, that has come to UNAM, that content changes over maybe a 3-year period of time, or the study period, or certainly between accreditation periods for top universities. And professors will then adjust the contents of it, as well as those who are teaching this. And then the students actually already getting a live adjustment to their work environment through that, as well as using their own experience in work during the studies. And then one would hope, and this is often the case, that we instructors at the university have ample enough experience to use the examples, or we rely on our knowledge that we know where our students are working to draw examples to match that which we're trying to explain theoretically to the reality that they face in work. Now let's switch to the other 3 months that they would be doing on a regular basis at the work. They will be then, of course, working for what their employer asks them to do, and they increasingly are then experienced or capable of then scaling that work according to the level that they are, whether they're first, second, and so on till final semester. As far as the challenges of the work that they're doing, they are also often rotating between different departments. See, this is an interest of the companies, because what they're doing is they're not just being good Samaritans. They are trying to first capture quality students. They know that they can't just hire people out of school and then hope to keep them, because most young people today see their future in a university education. So they're capturing them already from the beginning. They're capturing because they are already highly accredited or interested in being able to become in this program. These young people are very much motivated to come into the program because, after all, they're getting paid a normal salary. This is just the opposite of what a normal student usually expects in their university studies. They usually, like from the country where I was born in the United States, that costs a lot of money and you're in debt for many years. This is not the case. Our students can buy cars. They can live independently. They are financially not so hamstrung, is the word in colloquial language, by the economic situation. So this all motivation, they're taking advantage, these employers are taking advantage of to capture the students, keep the students then, and also see how do they fit to their business. In which department do they work better? And what type of projects or what type of inclination are they? What do they need? This is then at the end of the pipeline. I'm now jumping to the end of this program. I can use laser or I can use my finger, but basically you see this circle here, trading off between theory and practice. And I hope you understood a little bit about the dynamics that starts this ring rolling through the motivation of the students, through the motivation of the employers, and of course our university to help this thing go, so that in the end we're exchanging constantly this type of experience to promote our education, or for them to be able to work more competently at their position so that they end up being employed. This is employability. Now one should take a moment to consider what that means. The European Union, through the Bologna Accord, in 2010, now standardized university education, tertiary education throughout Europe so that all students can move from Portugal to Poland with the same accreditation as long as they're in a quality university. And in this case, they set a number of criteria that universities have to fulfill. But the most important criteria, bar none, is the term employability. And this is exactly what we're focusing on. And this is what we're already encouraging, and you'll see this encourage and later in this presentation as well, because indeed, we are so good at already getting the gist of the employability at the moment of the interest of the budding student to the point of the graduation, that these companies hire these people as best they can, 80, 90%, to not mention that some would then go off after graduation to do a master's program, or because they, for whatever personal reason, decide not to. This is a rather authentic number. This is also probably one of the reasons why our students are so desired. To give you an orientation of what this whole little dynamic is worth to companies, they value our students at graduation at about twice as much as what a normal employee is worth. That is a very easy calculation to follow if you can understand that the combination between what they learn through our educational system over the 3 years and the dynamics of the workplace, that is what it's worth then. See, if somebody is worth, let's say, a salary of $50,000 or euros, a company generally has to make about twice as much just to cover that and taxes of a person that they hire. Here in Argentina, it might be a little bit different, but generally speaking, this is throughout the OECD. Then, after you do that, you consider how much a company has to make on top of that in order to survive. Because, of course, if it's just employing people and paying the government, it's no business. In fact, it will, in the end, lose capital. Okay? So they've got to, that person has to be over time worth more than that. How much? Depends on how successful the business is. But well, let's say it's being 150, right? So how much is the student then worth at graduation? Our students are plug and play. This for non-techies basically is they can work from day one. And they know from the best universities, and you can take universities from Heidelberg or KIT or other internationally known universities from Germany, and they will take at least 1 year to get at that level. Get the picture? That makes a huge savings from our students. Now, just to close off this little introduction to what it is and the integration of theory and practice, maybe through one last example, through theses, and it can also be projects. The project and thesis ideas are proposed by the firms. They have some problem, a serious enough problem that they want to have solved, they want to get time, and then they give it to the student. Meanwhile, the student takes this, takes it to the program head, data science, or whichever program that student is working in, and needs to get it approved. So it has to be in the respective needs of that level, let's say a project or a thesis at an academic standard, has to fulfill certain criteria, academic ones, and it has to make sure that it is at the level of the education that they are receiving. So of course we are not going to do basket weaving in data science. We're going to be practicing that which is relevant to data science. And then also we're not going to do things that are out of the scope, even though one would like to maybe have it as a firm. But in particular then, it's closed in so that it is doable in the period of time. That period of time, including in the month of practice here, sometimes we have to explain that to our partners again and again, but that is reserved for that project or thesis because that's real work. And the company wants to make sure that that work is done well. It's getting supervised professors that supposedly know what they're supervising and know the material and encourage then a competent or an adequate level of that type of material and that solution to an up-to-date problem, and usually can apply even better tools than the company is aware of. And then it has to fulfill within that period of time. Let's say the project is a project of 200 hours. Those 200 working hours, think of it quickly, 40 hours a week of working. How many weeks of work is only for the project at the company's time? Okay, so maybe you can see through that example how much we are tied together and how much then we even go and visit the companies or talk with their internal company supervisors to make sure that these projects run well. Okay? Very good. Let's go. And here you can see, I mean, I've actually gone more into detail, but here you can see it across the timeline of what would end up being a 3-year program, and all bachelor programs with 200 and some. And it depends on how many ECTS you get it on the European accredited system, but that is, ours is actually above the level that one needs for a master's program, 210 ECTS or European credit. So they're trading off constantly, sometimes for logistics, both because companies are larger and they'd either have different groups at theory or in practice. They will then switch them, or because we at the university then need to also compensate with our infrastructure so that we can maximize the results. So that is basically the dual system program, and prepares our students then for the working world. Here, also a wrap up of the advantages of 3-month rotation between college and work and field, but maybe hopefully now through my examples you were able to understand that. The attractive thing for corporate partners, indeed, as you see here, they provide all normal coverage as well as what full-time employee would have. Monthly salary, content in small classes. Oh, then I forgot to mention, yes, our classes remain between 28 and 30 students speak. Okay? That makes sure that we can then supervise these projects, that we have enough people. And no, not every supervision is by professors. That would be an exorbitant academic cost. But interestingly, many supervisors of project or theses would then be people out of business, out of our partners themselves. And they would like to also be under the umbrella of quality university education in order to fine-tune their competence on things. Their knowledge of the business world, of course, is very up to date. And their driving interest, of course, from their companies or whatever their area of their work is also very good. So they are glad to supervise some of these or even instruct or helps instruct. It helps their curriculum and helps them show off, okay, we are at this university and so on. But in general, you see that we keep small classes and we keep a pretty tight supervision, the retention rate after graduation I mentioned before. So, and yes, we do have a master's program, and this in the end, not only as is common or modern today that we do master's degrees, whether or not one continues to post-secondary education to PhD or so, that can be a matter of debate and personal interest, of course, but in the dual system, it turns out, it's also very important. Why? Because one must understand after graduation, these students become valuable, and this is one of the reasons why our program is very hard to export or to have other institutions accept, because yes, those students or those new graduates, they're free to go where they want in the world, and all of a sudden they're very valuable. Now, we're not like in the football system where then they have to pay the company that educated them to grab them from their team. So, no, they're free to go. And because they are in such employability credence, the companies that, then have to be interested in trying to keep them in other ways. And the master's program is exactly one of those ways to do that. Because students are then also or young people in starting their career are well aware that a master's both increases their potential future salary as well as their own personal curiosity into deepening their understanding and education of a particular area of study. And so interest is mutual here to keep them in the company, and there we extended then another 2 years in the dual system. So we have a master's program as well. What could I add to it? Here we have international cooperation, but actually before I go into the international cooperation, let me go back to our bachelor program. We don't have the slide here anymore of how many different programs we have. Approximately through our 9 campuses, through our 16 different areas where we are close to our companies, through our 9,000 partners and so on. We, for our 9,000 partners and so on, we have across all our university approximately 90 study programs in business and around 70 study programs in engineering and around 20 programs in medical health sciences and around another 5 or 8 study programs in social sciences. So that is a rather broad gamut, and they are then only programs because companies want those to be there. In fact, if companies don't have any demand for them, we will reduce or we may even eliminate some study areas. So this is a clear market-oriented, let's say, way of shaping the offer and demand of what programs are to study. But they're very ample because, of course, the economy needs a lot of different ones, but they need to be up to date. They have to be ones that young people have a future in, and then a future where companies are willing to invest in them. And before I go into the international thing, let me just close up the other sort of open end that I left in the presentation was the matter of the companies. They're going in on a risk nonetheless in making in providing the opportunity for these students to work in their companies and giving them a full-time salary and giving them the freedom to go as soon as they're finished. And that is because they've become aware that what goes around comes around. So they become a desirable employee. They don't worry about benchmarking of competition. They worry about staying ahead. They worry about staying competent. They worry about attracting, and this is called now war for talent in today's business world. They're worried about their image so that young people want to come to them. And dual students are well respected in the companies. They tend to have a differentiating factor very shortly from the beginning of their studies, and this indeed reflects then well on the company. But, of course, this is a leap of faith. Now, after 50 years, we can show this. Well, we've been showing this for a long time now, but after 50 years, it's easy to bank on this, and this is why companies from all over Germany send their students down to this corner of Germany to study this dual program, even though they might have quasi-dual type of study programs, whether they are in Düsseldorf or Berlin or wherever else in the country. No, it's because indeed we are guaranteeing this employability and also the quality of education and helps the companies get ahead. So to close off here, the international cooperation, you can see that we're all over the world, somewhat concentrated in Europe, but here in Southeast Asia, well, in Southern Africa, and in Latin America, we have representations, as well as, where do we have this here? At point of the map. Posadas. And it's rightly there. And I hope we can build up on that. No. So, educational return with a leveraging effect, above average success, indeed. The students then can count on a good result at the end of the show. Economic independence. And if you can leave it on a humorous note, I mean, here I have a room full of our guinea pigs, our students, our conejillos de India. Yeah? And that is, I mean, at the beginning, they start realizing, hey, we don't have a life anymore. We're either working or we're studying. In fact, it's worse to be on campus than working, because there's a never-ending week, because then you get to do the homework on the weekend. But at least when work, well, at least, you know, on Friday we call it Feierabend in Germany. Then we have some break and can sleep it out. Well, in the end, though, they have a life. And this is, again, to give you an idea, feeling for this. Over these 3 years, an essential aspect of being very employable is being able to manage your own world. And you're not going to get everything done. You can get many things done well, and that's the point. And how do you manage your time? And so Here, they're able to manage full-time education, full-time work. Okay, they get paid well for that. They have an economic incentive. But in the end, they also have a maturity coming out of the program that is just unmatched in other university programs. Thank you for your attention.
Thank you. It's very interesting. It's very different. Very different. Here we have a pre-degree from 3 years, and after that they could do another 2 years and have the grade in licenciatura and bachelor's. The complete career of grade is 5 years. I don't know if another student wants to make your presentation, please. The post-degree here, the people must to pay too, and it's almost 2 or 3 years more, and have a lot of research work. Yes. Some questions? Do you have algunas preguntas? ¿Algo quieren preguntar?
¿Puedo explicar algo en cuanto a la diferencia de los países?
Sí, por favor, mientras ellos preparan la presentación, entonces hacemos unas aclaraciones. Si puedes hablar un poquito en español.
Porque la colega acaba de mencionar una cosa que parece a simple vista una incompatibilidad, que son los 5 años que uno tiene entre la licenciatura y bachillerato, y al final acaba siendo listo para el mundo del trabajo, y nosotros supuestamente solo son 3 años. Eso pasa en Alemania, concretamente, porque los estudiantes, estos estudiantes que están en el programa de 3 años, ya son preuniversitarios. Entonces, en Alemania, y eso tal vez de interés general, es que en Alemania hay 3 distintos sistemas o programas post-primario para acabar el secundario, que diferencia, antes era un 15-20% de la población, ahora son 30% y cada vez más, un grupo que son pre-anunciados para la universidad. Además, su educación son de 13 años y no los 12 años desde primera clase. Son 13 años, entonces ya viene a 1 año, y además su intensidad por ser especializada en pre-universidad ya compensa el otro año. Entonces, al final, acaba siendo 5 años, es de otro modo. El gimnasio. El gimnasio, ahí es una palabra que se alinda o se saca del lenguaje o del concepto francés originalmente, el lycée, que el lycée es lo que tenemos aquí también en Argentina como licenciatura, como la base de la misma. Ahora bien, eso no discrimina o no deja fuera de posibilidades de acceder a universidades a personas que no sean de este índole o esta demarcación, pero tienen que pasar 1 año adicional en educarse y prepararse específicamente para la universidad si hayan ido a los otros sistemas de escuela. Entonces ya ven que entonces 1 año más y una especificidad únicamente, no sobre las cosas primarias y tal, secundarias, sino preuniversitarias, tienen que compensar. Por eso, tal vez ayuda a comprender un poco mejor la
¿Cómo es la
diferencia.
diferencia entre lo que es el nivel secundario? ¿Cómo es la diferencia entre, si ustedes sienten la diferencia entre el nivel secundario y el ingreso a la universidad? O sea, ¿sienten, hay una diferencia?
Is there a gap between high school graduates and university freshmen?
Hay una diferencia, perdón, es que la diferencia es entre dinero, edad, ¿qué diferencia están buscando?
Here we have very different level of students.
Explícame en castellano.
El primer año para nosotros acá es muy difícil porque los chicos del secundario vienen con un nivel muy diferente.
Sí,
Entonces hay que vencer una barrera. Entonces, para nosotros
sí,
el primer año
por eso
es una
van
barrera.
digiriendo y compensando o recompensando, por decirlo de algún modo, el sistema o las faltas o las insuficiencias anteriores. Y además estandarizar la gente, porque claro, si uno tiene materia a nivel universitario, pero nota que la mitad de la clase ni siquiera tiene el vocabulario para seguirlo, pues no va a funcionar muy bien esa clase. Por eso están necesitando ese tiempo adicional, previo, sea lo que sea. Para nosotros también a veces notamos, por ejemplo, en competencias como estadísticas o matemáticas, o antes había el tema de inglés, pues se necesitaba recompensarlo y entonces necesitaban, a pesar de haber pasado gimnasio, a pesar de ser preuniversitario y a pesar de acceder a nuestra universidad que tiene un números clausus y además tiene que tener un mínimo de un 2, que es un nivel muy alto de notas para poder acceder al programa. Pues a pesar de todo esto, les damos unas 6 semanas intensivas del verano antes de que entran o no entran en
Sí, yo diría que sí.
¿Vale? Ahora sí le he contestado la pregunta.
Sí. ¿Otra pregunta? ¿Con qué edad promedio ellos terminan sus 3 años de formación de grado?
Was ist der Durchschnittsalter unserer Graduierten? 23, 22, 23, 23 años.
23 años.
¿Sí? Totalmente elegibles.
Con 23 años terminan
Depende de las redes.
Sí,
No,
sí.
no es lo mismo de Chata que cuando.
Claro.
No, ahora, nosotros no ofrecemos un doctorado de medicina, que por su práctica necesita un periodo mucho más largo de esta manera. Por decir algo, pues es el único estudio más allá de nuestro que ya necesita practicar la aplicación con la teoría de tal intensidad, pero ya ve cuánto tiempo necesita la medicina.
No, es muy interesante esto, ellos hacen la rotación teoría-práctica constantemente y vuelven a los lugares de trabajo y van y vienen.
Son varios elementos, son una larga lista de criterios que tienen que cumplir, pero son varios elementos claves. Primero, que las empresas eligen nuestros estudiantes. Nosotros no decimos, oye, este estudiante, no. Las empresas deciden y luego, si tienen el visto bueno de las empresas, vienen a nosotros. La segunda cosa es que todo lo que son su contenido, ¿ya? Lo hacemos mutuamente y activamente en el caso de los tesis o los proyectos, porque nosotros estamos supervisándolos, ellos están proponiéndolo. Yo no les doy que estudia esto, haga este proyecto. No. Las empresas lo dicen. Y finalmente, el currículum. El currículum lo decidimos mutuamente. Nos vemos con frecuencia a nivel jerárquico. Sí, ya lo ves. Mira. No, el currículum lo ajustamos. No en contra de los intereses o los estándares académicos. Esos son cuestión de acreditación. Pero sí en cuanto al contenido, entonces incluso los programas, o sea, ofrecemos más y solemos ofrecer más. Ya han visto, si tenemos 160 distintos, 170 programas en todos los campuses, pues ha crecido, ha favorecido mucho las necesidades. Entonces hay los en aeroespacial o lo que sea.
Let me be so that people can understand also. We don't speak English, they are
Learning Spanish.
learning Spanish.
They're learning Spanish.
Okay, let's do it.
I gladly I would do it, but I thought for your public here on the other end of the camera,
No, they can, they also can do it.
I understand. Very good.
What I would like, if you have time to listen to some of the students about their experiences.
No, they're going to give two presentations right now. We're just having technical matters and we're trying to clear them up. Are you ready? Okay. So very good question. Just before I close, you had a question?
Get in touch with the firms or?
How do they even apply? Okay, give an example. Anybody want to give an example of how you applied? How did you apply?
Yes, we apply at the company, and when we come. How did you get into the company?
When we are in school and we decide, okay, we want to make a dual student, then often there are possibilities to get in touch with the companies by so they present each other, but most of the time via internet. So you're just searching the company and then you find a company, it's interesting, you look it up. Okay, they have a dual program, then you apply by the company, and if you get accepted, then you automatically get a place in the DHBW. So the companies have places there, and when you get one of them, automatically in the DHBW.
So,
Just in this place because they
So-
have a good connection with the ecosystems.
the companies before the start of a new school year announce already, oh, I'm company X, I'm relatively new, or I'm relatively small. I need only one or two. Or I'm company Y, I know what I'm doing, I've been around, and I need 130 new students, SAP, for example. And so what they will, and they want 12 from this department, 20 from this department, and 40 from this department, and from data science more than they can get. And then they announce that. They announce it online, they announce it in job fairs, they announce it in at schools. There are presentations that go around to high schools and show in little work fairs or little presentations, dog and pony shows, what is on offer. And so people are interested. And so through those different channels, young people find out about this. The dual system in itself is not needed to be advertised anymore. That's pretty clear, certainly in our corner of Germany, but actually in all throughout Germany. Okay? But once then they've announced their offerings, then students apply for these, or future students apply for this, and then the company interviews them just like a job interview, and then they get accepted or they don't get accepted, and on goes the story. Very good.
No, it's fine. Okay, perfect. Yeah, thank you everybody, and yeah, great to be here. First of all, thanks for the great opportunity. And yeah, like Professor Holschuh already mentioned, we got like also combination from theory and praxis. And practical phases, and yeah, especially this project has been done through a theoretical phase at the DHBW in Mannheim, and Luis is presenting a project from the practical phase at the company. Yeah, and therefore I will show you today the DHBW Assistant, which is a kind of proof of concept project for a digital assistant for the DHBW. And we were facing the problems that we had like different tools, different sources of information, like different websites or different apps to use to get the student life better going on. Yeah. Yes, so the main idea is basically to have a digital assistant for the students at our university. And it's kind of a one-stop solution for all student needs. As of now, the students have to kind of access different platforms and kind of get the information from different sources. And this digital assistant should help the students get better access at like one point of entry. This business case is kind of like a monthly subscription, and should help to refinance the digital assistant. Yeah. For the architecture, it's kind of very basic. We have like front end and back end, and in the front end we use like Google libraries like Flutter, Dart, and Material UI 3, and basically have multi-platform access through various APIs. Also using OpenAI in the backend, and that's basically the structure. And the front end helps to have kind of a simple UI to access the bot, and in the backend kind of information retrieval magic happens, and therefore we use kind of these technologies. Yes. Okay, so basically what we are doing in this digital assistant is kind of retrieving informations from various sources of data. And for this kind of infusion of informations in digital assistants, there's kind of a system called RAG, or Retrieval Augmented Generation, which can help to provide business knowledge or domain knowledge to digital assistants. And in the first step, we have like the user entering a message into the chatbot or the digital assistant. Then in the second step, we have like our search engine or retrieval augmented generation engine, which kind of takes the knowledge from external sources like documents or online searches. And especially in this part, it gets tricky because you have to access various APIs and functions. But then the results are returned back to our kind of search engine or retrieval augmented generation engine. And then we give this information together with the user context or the user intents or entities to an LLM in this case. It's like, I think, OpenAI's GPT-4o, which we use, and therefore the answers generated and given back to the user in this case. Yes. So here we got like an example chatbot workflow in this case. So when we look at it a little bit closer, I don't know if you can see it in detail. It's really hard, but I can try to explain it. So basically, here the user can create its own assistant and create a thread. A thread is kind of a message, like a WhatsApp chat or something like that. And then here are the different functions the user can access. As of now, we have like the get bytes function, the get weather function, the get next lecture function, and the get next lecture date function. So these are, as of now, the functions which we can access through this digital assistant. And that are the functions the user can use as of now. All right, to show you a little bit more, I can just open our digital assistant now. Yes, so here we have like our homepage. It's like really Google style, as you can see. So that's like the the Google UI page, and here we have like an overview of the different APIs, like the Nextbike API with the current location of the DHBW, and also the weather information and the information for the next train for the direction to the Mannheim city center.
Is this up to date?
Yes, that's actually live, so...
4.3 degrees centigrade.
Yes, so we have like 1622 here now, and it's like 2022 in Mannheim right now, so the next train would be NG6 to Hans-Thomas-Straße, yeah. Okay. But the best feature, of course, is like the chat, and there we can like try to access like different functions. For example, how is the weather in... Okay, hope it works now. Yeah. Okay, so yeah, here for example you can see, okay, the assistant executed the get weather function therefore, and kind of grab the result and yeah, put it into the chat. That's also what you can do with like the next bikes or the get next lectures. We can also try the next bikes, for example.
Can you increase the font size a bit?
Yes. Yeah, okay. So okay, yeah, that took a little bit longer, but here we also get like the results for the next bikes. And for you to understand, the next bikes are like rental bikes which students and yeah, people in Mannheim can use to go from A to B, for example. And to look in detail how this works, we can go back to the presentation. Yeah. So what we implemented here is kind of retrieval augmented generations to actions. That means like the user enters a specific input in our chat UI, and then retrieval augmented generation selects the correct function to execute based on the function description or the text we provided. And the function is then obviously executed, and the results obtained from the API, like the weather API, the Nextbike API, or anything else. Yeah, any function we provided. Then the input is processed and kind of formatted and put it into the LLM, also with the user context and the chat history, for example. And yeah, then the response is generated. And here, for example, we have like the get bikes function, and like I did in the chat, we have like a question like how many next bikes are available at our university, and then we can yeah, see how rec selects the correct function. And here you have like, I don't know if you can read that, but you can see like how a function looks or how a tool of the digital assistant looks in our case. You have like the function, like get bikes, and then you have like the description of this function. And this description kind of helps to, based on the user input, helps to find the correct function. And in the back there's like, it's handled with embeddings and vectors, but in this case it's based on the description, and the description tries, or rec tries to match the closest description yeah, to the user input. Yes, so here the function is executed, and like we've seen in the example before, we have like DHB Mannheim, and we don't actually have like the name DHB Mannheim in the database of the Nextbike stations, So we do like another retrieval augmented generation to match it to the fitting stations. Yeah, and that's basically it to get the corresponding station. Yeah. Yeah, so in the end, the input is processed within the LLM context. So we put like the result of the invoked function there and the chat message, and then we get like the generation of the answer, which should help the user and kind of give him faster insights into his needed information. Yeah. All right, so that was one of the projects we have done in the theoretical phase in the university. So thanks for your attention and happy to take your questions. Yes.
How do you plan to spend in this project?
Sorry?
How many times do you spend?
So normally, like was shown in the other presentation, we have like 3 months for the whole theoretical phase, and I think it was approximately like 2.5, 2 months. Yeah. More questions? Yes.
How much does the backend cost?
I mean, it depends on how much calls you do to the assistant, but I think we tested it like, for this demo, it would be like 2 cents or something like that.
Per query?
I think per query it would be like 1 cent or a little bit lower, yeah.
Is there a way to see how much traffic there is right now to the behind?
Traffic, I don't know if it works right now, but we can test that. So okay, but for your cost perspective, let me. Yeah, so we also implemented kind of a statistics page so that you can think of, okay, if the costs are getting too high, like students like putting in everything there, like in ChatGPT or something, we have like also like a artificial boundary to say, okay, every student has an amount of 10 inputs per day, or like inputs in specific fields, like a student can request bikes 5 times a day or something like that, to kind of regulate it, to regulate the cost. Yeah.
But you want to know the traffic?
I don't know if it works now, but we can check.
Just decrease the font size?
Okay. So here we also kind of put like the Google Maps API in the backend. So I don't know if that's actually coming from the Maps API right now, but in generally we have like the Google Maps API in the backend to see, okay, in combination with the calendar from your next lectures to see, okay, when I have my next lecture at 9 and I need half an hour, then to check, okay, with Google Maps, how or when should I go, or like, should I take the bus or the metro or whatever. So that are kind of scenarios we are also experimenting with to see, okay, how these different functions can work together. Yeah. Yes?
Could you store the chat that messages that the user enters, and how do you manage privacy on that?
Yeah, so as of now, we are just giving or storing the last 3 messages of the user to kind of keep a little bit of context. Like when you ask how the weather is, and then the assistant answers, and then you ask like Berlin question mark, then it has like the context. But after that, it's kind of overwritten, so it's deleted, and the assistant or the API of the assistant just gets the last 3 ones. Yeah. Data privacy, yes. So the documents we kind of uploaded, or the user can upload there, like his lectures or something like that, are as of now saved in a local vector database. So we kind of set up a local vector database, yeah, to not publish it in the internet. Yeah. Okay, then if no more questions left, thanks again.
So wir das generieren kann. Das ist ein Icon. Auf dem Bildschirm da gab es kein Icon. Das ist also Ihr Präsentationsmodus. Jetzt nochmal. Wo ist Präsentationsmodus dann? Zeig ihm. Präsentationsmodus. Er sucht es. Auf jetzt. Aí aber müssen wir Presentation? Nein, eben. Es ist Ihr Programm, deshalb. No, it's not mine. Is that your laptop? No. ¿Dónde tienen su laptop?
Das ist kopiert auf den Bildschirm. Jetzt müssen wir underlying. Das hängt nicht mehr zusammen. Das hängt nicht mehr zusammen. Ich glaube, das nur bleibt. Slideshow.
Das ist der Post.
That's not like.
I can try mine.
Do you have any dynamics?
Frankfurt waren oder sind?
Ja, ja.
Ist es bei Gebäude?
Okay, so thank you for having me. I'm going to present you today something about my three practical phases. My first practical phase I spent with time series analysis. A quick introduction what it is. Time series analysis is what we know what helps us, our planning in our company, to see something in a different or see what our data in the past looks like. Every business is doing their plannings for their own possibilities and of its financial resources. So the sales and maximization their profit is pretty good. So I'm working for the DB. It's called Deutsche Bahn. It's the German train services I'm working for. We have about 340,000 employees all over Germany. I am, as you can see, one of 1,500 students in these cooperative studies, as all of us are. I'm working in Frankfurt, which is located in the southwest of Germany, which is our main or headquarter of DB. We have around 2.73 billion passengers in 2023 and punctuality with around 80%. In Germany, punctuality is every train which arrives within 5 minutes after their planning time. So the definition of time series. A time series is a set of observations taken at a specified time. Usually it's at equal intervals. A time series establishes relation between cause and effect. And time is independent variable where data is the dependent one. So here you can see the dependence of the time series. First we have the trend. A trend is something like the population which is increasing every year. We have the cyclic component, which you can see here. Here something like day or night. This is a cyclic dependence. And we have seasonal variation, which is like in winter, or we have another. We have other people, or more people traveling by train in winter than in the summer. So here, unfortunately, I'm not able to show you real data from DB. So here's a test data set I'm going to present you. In this, we see the trend. With a regression, we are able to remove this trend. This is very important for time series analysis. We have 2.66 more passengers per month. And after this manipulation, we see that our numbers is between plus 150 and minus 100, which is around the zero, around the mean in the zero. This is because of the seasonal dependence. To remove this seasonal dependence, we make another step. As you can see, there is an average of over 60 more passengers in July than overall average. Also, these 60 are in November with minus. Through trend and seasonality, we have already been able to explain most of the variance in this data. So our last step is to make or to count the autocorrelations. In the first column, we can see the relationship to the next time step. So plus t plus 1 and t plus 2 and t plus 3. And we see a linear dependence between t and t plus 1, which is going to be less and less. Now we could compare t plus 1 to t plus 2, but that's not what I have done. So this is already pretty good for our data. So we had some problems in the past. The first problem was COVID-19, which is the passengers are staying home, not traveling by train. This made our time series analysis pretty different and hard. Another problem is the €9 ticket. In Germany, we had after COVID-19 the €9 ticket, which is here in Argentina we had the SUBU card, SUBE card. In Germany, we are able to get this card for €9, and then we are free to use every train, every regional train from the south of Germany to the north. And this was used by many people. So we have a high peak passengers in this period, around 1 year. So here's another application we made in the DHBW in the first year. This is a test data set. We split it in two parts. The part from 2011 to the part of 2019, which is our training data set, and a part at the training set, and a part till 2021 to test our model. Here you can see our prediction is pretty nice. We see our train data set till 2019 and our prediction till 2021. The dark blue line shows the real data, and the light blue is our prediction, and it's everywhere it's in, so it hits perfectly. We made another try with the gold price or stock market. As you can see, this does not go well. This is the border of time series analysis. If anybody is able to predict the price of gold, please tell me. You're going to be pretty rich. In my second practical phase, I worked in the congestion management. I worked a lot of graph databases with Neo4j, for example. We developed a digital twin of our infrastructure. The goal was to create a more robust and better use of the existing infrastructure. There are 3 points we looked at. That's first the short train sequence, so one train traveling after another train. We looked at the route merging, where trains merge and we looked at the crossing situations. Because of our infrastructure is very bad, we have those crossing situations very often. By adjusting the timetable of 7 trains, we were able to save 6 hours of waiting times for all passengers in the center of Frankfurt. My third and fourth practical phase, I spent in a team developing a front-end platform to track the trains with their faults and the report, and to give instruction for the fault clearance. We also used AI for classification of these faults, and AI is already able to clear some of them. We already provide real-time support for the driver of the train, and we are saving around 30 trains per month, which is increasing. This project is around half a year old. So that's it. That's my practical phases. Thank you. Dankeschön. Muchas gracias. Are there any questions? Yes.
What does it mean if you save 30 trains? So is it like they are not in repair and can be used? And is there like a price tag? Do you know how much money you've been saving because of this tool?
I don't know a price tag, but I can explain you a story. For example, one train stands in France and had a high temperature in the wheels. So the train driver wasn't able to drive further, and due to our real-time train data, we were able to say if the train is driving slower, a little bit slower, it's still able to come back to Germany in the maintenance, and it's not cancelled. Yes. Yes.
To get me the year.
Yes. Yes, the €9 ticket is still not available. Isn't still available. It's now around €50, I think. 49. Okay, are there any more questions about the dual system, German train services?
Well, I have a lot of questions, but maybe we'll go here. Okay, thanks.
Okay, in this part of the presentation, we will hear Martín Rey. Thank you. Take your place here. With mate. Yeah. Mate too. Okay. He is one of our teachers in informatic careers. And he worked too in another faculty that we have in our university. Is the faculty that you will visit tomorrow, economic. He worked there too. Se ve muy grande.
No, it's not enough.
No. It's not working. Ahí está un poquito mejor, sí. Si abrís la presentación. Here we go.
Bien, empezamos. Bueno, hi everyone, I'm Martin, and I am going to talk about how we are building a data lake for management and processing research activity data. This work is located in the Northeast Economics Research Institute that belongs to the Economic Science Faculty of this university. And, well, something about me. I don't speak German, obviously. Sorry about that. I am professor in this faculty in the computer science programs, and kind of from 2010. But I work in the Apóstoles city, the capital of Yerba Mate. Also, I'm part of the Research Institute on Computer Science. And also, like Alice said, I work in the economics faculty. I'm going to stop speaking English in this moment, and I'm going to continue in Spanglish and rely on the translation services over there. Thank you. Bueno, para comenzar, vamos a ver una introducción, nuestro problema, la solución a la que estamos tratando de llegar, el stack tecnológico, una demo y algunas conclusiones.
Y
si quieren, freno un momento y ahí traducen, si quieren. Hacemos así. Bueno, la transformación digital en cualquier organización es un proceso complejo. Dentro de las universidades esto no es una cuestión ajena y no alcanza únicamente con el establecimiento de sistemas, sino que requiere de otro tipo de soluciones adicionales.
Okay. I know the translator, just a teacher. So he says there that the digital transformation, I'm going to just read what the PowerPoint maybe, puede ser, porque dice
Sí.
So the digital transformation in universities is like a vital process and for the improvement of the university. And there are functions, especially in the areas of science and technology. The UNAM, our university, UNAM is our university, has implemented a system. There it says for a range of years between 2012 and 2016 has implemented a system called SASP. We have that system, and the aim of the system is to manage research projects more efficiently.
Okay, in English, why are you translating? Sorry, English.
Yeah. You can read. If you can read that, it's fine. I'm going to add. Maybe I just add something about that. Okay, that's our context. See, yes, and we think that the digitalization is not complete if we don't add a layer of tools that empowers the decision makers. Yes, and we think that is based in data that we have. So we want to identify the different sources of data that we already know. We want to analyze that in order to get what data is in that sources, because in some point you have to talk with an expert to really understand what is the meaning of the data that is stored. So over that, we want to construct or develop a tool for support for the decision-making processes. All of this is focused on the research activities. Yes, like a research work or research project. Sometimes that involves only professors of the university. Sometimes that works with some organizations outside the university, like I don't know, like a business or something like that, or our government office. Well, our problem is that, yes, we have the data, but it's distributed in a wrong way. Yes, not in a funny way like a distributed system, but is in one system, in other area. People have data in their own computers because they manage the inscripciones, the registration of a certain event or something like that. We have another sources of data, but they are not used at all. Yes, we only rely on the SASP system that, además de esto, besides registration of projects or any activity, it doesn't storage the whole history. Yes, we don't have a photo of the people that works in research activity in certain moment, sino que lo tenemos a día de hoy.
It's not today.
We have only the data for today. So, my case is that I work in a project 5 years ago. In that moment, I have only my bachelor degree. Now I have my master's degree, and that degree is on the 5 years ago data. That is wrong for the analysis that we want to do. That is the point of historical data not fully available. And the last part that I said before, that we know that a certain kind of data is only managed by some people, and if that person is not here, we can't access that data or we can't understand that. So what is a solution for this, or a possible solution? We think that is construct or build a data platform, in this case a data lake, in which we can process all that data and get an idea of the impact of every activity in the research results that our professors as a group get. Additionally, we want to get a model or a solution for visualization of that data, because if we can see the data, we can make decisions with that. Yes? And also to generate indicators que podamos exportar a otros.
That we can export.
That we can export to another organizations, not only on the university, but in the government or something like that. So, what are our data sources? The SASP system own records of every, no sé cómo sería secretaría. Sí, pero secretaría como área. Secretary. Sí, bueno, secretary area of research in every faculty. Added to that, categorization reports, and ahí me meto en un problema. Every professor has a category based on his research. Yes, and every 5 years, 4 or 5 years, you can ask for a better category, and that allows you to dirigir
organize or
lead a team of researchers and keep going up in the pyramid. Also, we have some metrics that we want to get, we want to show to the decision makers, like the quantity of professors that are categorized and they are working in some activity, how many not are categorized and working in some activity, that. What we have done. First, we went through a process of pre-processing data, because the people that the storage in some moment have something like this, in which we have different years of the categorization process and the results obtained by the professors. This is kind of difficult to process. Yes, kind of difficult to storage in a tabular form. So we first want to convert that to a format that we can use and we can analyze in a programming way. Also, by any activity that is a project or a work that, in fact, that doesn't have a really big difference between them, but one of them can get money, can ask for
funding.
Yes, one of them can be funding, another no. So we managed to, we have here all the participants in the project. We managed that to make one row by any person, taking into account what is the kind of activity and the role of the person. We are in a moment of the project in which we have developed a proof of concept, and that was a data lake. Why a data lake and not a data warehouse? A data warehouse is more focused on a business problem, a data lake not necessarily. Why not a data mesh? Because we don't have a distributed problem with the data. In fact, más allá de lo que dije anteriormente, besides what I said before. So the data can be in one place. So that is going to be our data lake. Maybe a data lake house in the future. This is all our full proposal. The code name for the project is Orca, like a killing whale, yes. We have our data sources that is going to be in storage in our data lake that has an object storage and metadata database. And we have several ETL process. With the definition of different indicators, we want to process the data and get the value for that indicators. Like I said before, we need different visualization and applications or solutions. And also, we want to be prepared to apply some machine learning or AI processing into this data. Our tech stack is by now MinIO for an object storage, Apache Iceberg for the definition of tables. For the visualization, we are using Streamlit. For data processing, Pandas, and to dev, Docker containers. What industry recommends is that, yes, we want to, in the future, get something like that, but it's not easy. we are not so much people working on this. In the technical side, I am going to talk about the team after this, sorry. But we know that we have to go in this direction, yes. But in the process, this is what we have. Like a demo. This is our bucket in Min.io. This is a local instance only for showing this today. We have maybe 2 data sets that are stored here. We went to different Jupyter notebooks to make some tests and maybe look into the data and try to understand that and try to know if that data that we have is it's okay by our objectives. So these are the projects and the distribution of kind of people that is working in every one of them. Some students, professors, graduates, and ¿cómo sería? Administration persons, yes. Also, we have what kind of activity we are collecting data from. The majority are projects, some works, and some are a special kind of project that has a social impact. Also, we have all the categorization results of the last evaluation phase, and we have the distribution of every professor in each category. Over that, we want to know if for each project, how many of the team that is working on that project is with or without a category, and that are the results. We want to make an average overall, but for a proof of concept, we think that this is okay, and we want to we build something like this in which, in a very simple way, we can present to decision makers all the data that we have formatted in graphics that are obviously mejorables, improvable, but for a first approach to this problem, we think that it's a valid result. So some conclusions about this. First, we think that in a technical and a functional way, the project is it's possible. We think that our results are going to be useful for the decision-making process, and this line of this topic is going to be formalized as a real work or project of research or project or work in the future. We think the next year. And by this is our team. Es parcialmente de la Secretaría de Ciencia y Tecnología de la Facultad de Ciencias Económicas, la directora del instituto, 2 integrantes y, bueno, yo como parte más técnica, y en el futuro estamos pensando incorporar más gente de la parte técnica justamente para sumar fuerza en este apartado. All of them are the experts, the domain experts, and we want to add people in the project that complements the technical part. And thank you. Sorry for... Si no hay preguntas es porque...
How much data do you think you will need to store on this data? Like, is it in the scale of gigabytes, terabytes,
La cantidad de datos que necesita.
Now, by now is really small. That two files are for 1 year only. Okay. It is a change. These two files are for 1 year only, and that is other problem. We only have the last from 2016 to today data. We are discovering new sources of data every day, but I think that in a gigabyte scale is more than accurate for this project. It's not going to be a big data lake, but I don't know. Maybe if in future this extends to another faculty, and I don't know, if we mix all the data for the new university, maybe. But I don't think that more than 10 gigas, and it's all.
Pero esto es solo para ciencias económicas.
En este por ahora sí, porque la realidad es que fue una idea en una charla de una tarde y nos autoforzamos a formalizarlo para una jornada.
Because this project is just one faculty, but the SASB system now has the data of the whole university. If the project will be improved with all the data, I think that it will be more bigger.
How many faculties we have? We don't know how many faculties.
Okay, we only have seven faculties. Yes, we are a small university in the context of the whole country. We have only seven faculties and kind of, ¿cuánto? 30.000 alumnos. Algo así. It's difficult to know how many students we have, but 30,000. 30,000, yes. Students. Professors? I don't know. Yes. We don't have that data, yes, in this moment. Yeah, maybe it's like an over-engineer or killing a fly with a bazooka or something like that. No sé cómo expresarlo de otra manera a la comparación, pero but I think that it's not about how much data we have. It's using this as an excuse for implement a government of data initiative that allows all of us, first in this faculty and also in the future, maybe in others, to know what data we have, what data we generate with all activities, and how that impacts on the results of every project, every research project or work that our professors do in some time. Because maybe you organize a venue like this, yes, or something like a congress or something like that, and you don't know if, I don't know, maybe 20 professors present a work or a paper in that congress. Is that important for the university? That makes a difference or not? We don't have that kind of data in this moment, and maybe the solution is really big in a technical way, but the objectives are more related to the government of data situation, or data government situation.
At least that it's not about the size, but about how useful it can be for our university management.
Yes, it also is more related to data quality problem, because the data in the SAFP system is it's okay for their objectives, but not for a long-term process or long-term decision making. So with that in mind, we think that something like this is going to be a better solution.
Are there any other questions? No? All right. Thank you so much.
Thank you.
Buena.
Va al revés.
Well, hello everyone. I am a professor in the National University of Misiones. The work we do now is about a distributed data management for IoT applications. The problem when implementing Internet of Things projects in the rural context is the data from the sensor node go to the cloud, and in the cloud is processing, and in processing the commands, working, going to the nodes to alter the actuators in the node. This is a problem because exists a high latency in the transmission, and the flow to the cloud is constant. The cost to storage the data is high in the cloud. And in the rural context in Argentina, the connections to internet is unstable. And if the node is connected direct to the cloud, when not exists connection, the data is lost. Our proposal is to create a distributed data storage where the data resides in the edge and in the cloud. And the user query the data local to the edge and in the global form from the cloud. The project scope is the horticulture projects in the rural context, because it's a work when I working the last years. And the components is nodes, functional and actuator nodes, working with ESP32 nodes in using ESP-DF framework. That is a FreeRTOS operating system. The Excel software working in Raspberry Pi or Beagle board in have a local storage and a full system. Initially, the local storage was a transactional database. The data in the local storage has a time to live. When this time passes, the data is compressed and transferred to the cloud. Has a dispatcher service in the cloud for the global queries, and the dispatcher has to connect to the storage service in the cloud and have a metadata of the edge nodes exist in the systems. The cloud storage service is a S3 of compatible system in EO, Garage, others. And this is a proposed system. Initially, the sensor and actuator nodes transfers data captured to the edge node, and the edge node have a rule system and a storage service local to the edge node. It's possible to realize.
¿Puedes poner el micrófono más cerca,
Perdón, sí. Sí. Lo voy a decir en español porque no me va a salir en inglés, sí. No estoy acostumbrado a usar micrófono. No, es un tema. Eso podemos hacer. Un chamamé. Sí. It's possible to realize local queries to the edge node, and when the time to live, the data is compressed and transferred to the cloud, to the storage service. The dispatcher service accepts queries from the client in the cloud and transfer the queries to the storage service in S3 or compatible, or to the edge nodes. In this case, the benefits of this system is reduce the latency, because if the rule engines exist in the edge node, see, the data transfer is the time to data transfer is slow. The increase reliability because if the internet service down in the rural environment, see, the ETC node continue accepting data from the sensor and actuator nodes and storage the data in the local storage. Prevent data loss because the data when no exists connect to internet is storage in the local storage, okay? And it's possible to realize real-time decision making because the latency is down. And when I separate the dispatcher to the storage in the cloud, it's possible to scalability the number of dispatcher process when exists a high demand of queries from the client in the cloud. And using disaggregate storage, by the way, using STS compatible data storage permits to administrate the storage independent to the query processing engine, which is the dispatcher. And this is a benefit, and it's very, actually it's very using in other projects, for example, SlateDB, Monotone, and exists a variant of MySQL to save in the stretch, for example. Our team is one professor from the Embedded System Laboratory in the Engineer Faculty of National University of the University of Buenos Aires. 3 professors for the faculty in the UNAM. And was one master thesis in process from this work. The objective is to the benefits of the rural producers for the technology permits que tengan más tiempo libre, more free times. The contact for me, send you questions.
Thanks for the talk. Do you have any real world use cases where you have tried this kind of setting?
I'm working for my project.
Ah, okay.
I have previous projects from and use CouchDB in the data in the cloud using DigitalOcean, Docker Swarm from the ¿cómo es que se llama? For the containers and the scalability embedded in the nodes.
Have you tried this out in, let's say, real IoT project, like real sensors?
I'm using, say, SP32 and real sensors, but the hobby is using, ¿sí? No es que uso placas como industriales, industrial. Gracias.
Okay, thank you for your time, for staying here with us. Are you tired or have a little time for one presentation more? No, please. Yo tendría que usar una de esas compu para bajar, porque yo tengo en el drive de Google la presentación. No sé. Okay. I just tell you without presentation. I have in a Google Drive my presentation, okay? I just want to tell you about our institute. We have an Informatic Institute. The people that work there is all people that are from the research project, and they can stay here. Just they send me the presentation and ¿querés? ¿Sí? Bajamos rapidito. Yo no los quiero cansar. Okay.
Dale. M.Rey00. Ahí te lo compartí.
Okay. Here in our faculty is exact science. We have 4 careers. Two of them are the pre-grade. I can say the name of the career in English. Tecnicatura en Tecnologías de la Información. Analista en Sistemas de Computación. Yes, and 2 great career. One is a computer professor, and the another one is a bachelor's in information systems. That is the 4 careers that we have in this moment. And after that, we create post-degree careers. One is especialización en tecnologías de la información.
Technology specialization.
Maestría en tecnologías de la información.
A master's degree on the same field.
Ajá, y el doctorado en informática.
And a PhD in
Informatica. This is an institute. This is a special way that we put together our research project or the research professors and post-degree careers. This is the director in this moment. Is the director, no? Yes, is the actual director. You know that the data science is the mission between big data, deep learning, and machine learning. And all projects must to work together with all this area. We learn to machine for recognize the difference between a big data, I don't know, en gran cantidad de datos, ¿sí? Okay. When we have a big data, we learn to machine for recognize some difference in this data. For example, in an image or video, we can find a liquid lake or another anomaly in the system. In this moment, we know that deep learning is in the part most important of the wheel. We can talk about generative or LLM, like the project that you show us. And this moment, the most important is generative, cloud native, and EA augmented. We have another professor that is not here in this moment. His name is Fabio, and he worked with augmented AI. Our institute is called Institute for Research, Development, and Innovation in Computer Science. Is one part of the Faculty of Exactas, and the vision is have a special area that work with computer engineering and make improve and innovation with technologies applied in regional and national work. And we must to become a center of reference for this work. The first program was in computer research and was born in 1999, no? Okay. 2009. 2009, okay, yes. 2009. After that, the Institute research born at the 2029, yes. What we have working into this institute, all research projects and social development technology and projects for our teachers, all the final degree projects here for receive the last term of the career, our student must to do a final project and defend. All these projects could find a work or place in the institute. Postgraduate thesis and scholarship holders to you. We don't have a system working with las empresas on ¿cómo? Companies. Well, we don't have here a good system like yours working with the companies. We must to find for the university and talk with each company and try to make some place for our students have a way for do the practical internship. The internship, just in degree and post degree. It's a hard work for the university find this place because here the companies don't want to receive the students. We have a figure that called PPS and another figure that called pasantías. Internships. Okay, internships, but the company don't want to receive all the students. It's very difficult. Big companies like Arauco is here one paper company in the center of the state, and they have international presence. They receive our students because for there is no problem. But here in the region we have a lot family companies. They are not too big, and it's a problem for them to receive students. Then the institute tried to provide these training opportunities for the student, help us to find some companies or even in the research group Yes. Well, here is one of the post-degree career, specialization in information technology. Another one is the master's degree in information technology and the PhD in computer science. Our work space is in different kind of work. For example, risk analysis, find outliers in the data, data mining, working with biomaterials, successful factors in academic research. Auditoría, how do you say auditoría? Auditing work when it is when a professional go into a company and try to explain good practice and try to see when these practices are working in the company. Yes, something like that. That is auditor. Embedded systems. Digital document gestion, ¿sí? Gestión documental. Digital repositories, software engineering, and even support for education architectures. One of the work that the Institute has made is about a tools deployment for public water quality management. This is one project that I'll come back again. With another university, University of Valencia. This is a master degree thesis, final work, that work together with the Institute in the partnership, and it's about monitoring in real time all hydrometeorological and physicochemical variables. They have sensors in each place along to the river and taking in real time the measurements about the hydrometeorological and physicochemical variables. The objective of the project is find the source and characteristics that we can take for measuring the quality of the water, make and processing and improve this processing, recollect, to collect the data and put this data into a model, and find a correct machine learning model support for find into all these recollected data these indicators that show us the quality of water. Sorry for my English. I am doing my best work now. The context. The most important was detect the contamination and optimize the water and find the sections that are the most important in all along the river, no? The most important place and the most important sensors working, because each sensor is money. And now all the sensors take the correct measures, and we must to find what is the most important collectors. Locate these points in geographical points and make a processor that we can maintain in the time, no? Continuous control. This Ciencia is the name of the, in Valencia, the name of the project that collect the data. And they have stations that call multi-parameter units, and this station facilitates us the immersion of pH, potential hydrogen, temperature, conductivity, and oxygen dissolved in the water. They may also have an phosphorate analysis and allows to find some correlation of organic and matter in the water, and even mention about another organisms present in the water. The system have developed some alarms, establishment some parameters that disparan las alarmas, shoot the alarms in the important moments, and when occur on fails, or when is about on risk detect or problem security. Here is some of the values that determine the point of shoot of every sensor. Yes, the limit of the
Threshold.
threshold. Yes, the thresholds. Yes, the thresholds. The point that they put the alarm. With this project, the people must to consider the existence of any incidents that could make a difference in the water quality. One of the works that made into the project is analyze the behavior and factors for the turbidity of water, how clean is the water, and identify analyzing the time series and propose an evaluation, yes? The data mining project that used in this project was based in this bibliography. What we can do with this project is missing data and evidence of physical chemical parameters in the water, possible failures and rules and atypical parameters. This is one graphical of the data recollected, and we can see here one moment that we don't have any data because the sensors don't work correctly, and this happens too in every project. This is a prediction, and what passed over the prediction are present the two scales, the real values and values prediction for the models. Another project that we have in the institute.
Could you go back one?
Okay.
Everybody knows what NTU is. NTU, the Pherometric Turbidity Unit. The unit of the measure of turbidity. Turbidity is when particles are in the water. It has not to do with color, but with the particles of the water. So when river rise up, come a little dirty with air from it. So change the quantity of particles on the water. So the turbidity grows up. The global turbidity is how many particles are. This is the pherometric turbidity unit.
Yes, thank you. How not clean is the water? Another.
And here it seems, wherever you've been measuring it, it seems to be dirty in the summer months.
Yes, when flood comes.
Here in Misiones is very difficult.
And it seems to happen more in November and in February.
There's nothing to do with that. It depends how hard it rains in Brazil. If Brazil rains a lot, come dirty. So it's clean. That's right.
Here is aerial graphical of our forest, and we try to find especies de árboles, species of tree, and detect how species are into the forest, because we have a lot, like Arauco, forest that is not native, is for...
Arauco's paper.
Yes.
It's a Chile map for Chile.
Yes, if you see an area photo like this, you'll see all green, but no, this green is real forest. Yes. Here we have an endemic problem called dengue. I don't know if you have called about that, but this is a project that tries to classify the stereotypes in the different analysis. Yes, blood analysis. Another project is the digital transformation of the documents that are in the Honorable Tribunal de Cuentas de la Provincia de Misiones.
That is the office to have a look about how much people the government spends.
Okay.
The accounting office.
Okay. It's one institution of government.
We like big names.
Yes. It's one institution of government, and we work with the institute for make the digital transformation of all the documents that they work, like Edigesto and OCR recognize, yes, optical character recognize, yes, for the documents, and make a digest about these documents, yes. This is a web project, it's a portal for show the documentation to the public. All the people can ask about the documentation present in this organization, and they can download and find for different methods. Okay, this is the mail of the director, and this is all about our institute. Thank you for your time.
Only 5 minutes. Before leaving. As a matter of fact, the secretary here has talked about only one institute in our faculty. Our faculty has many other faculties or careers, let's say chemical engineering, food engineering, biochemistry, pharmacy, genetics, nursery, and they need a lot of data science, not only informatics. Let's take the genetics. Genetics links from ADN, RDN, and so on, with data science. But our dean, the dean of faculty, is much interested in making some agreement with you to work in that, working with ADN, RDN, and so on, all those items. Because people here are embedded in informatics things, but not many on what the faculty today needs. Today, the faculty needs to go on some improvement in genetics management, how to prevent some diseases in pharmacy, how to develop new treatment for people, okay? New medicament, new drugs, how to prevent. They are working on dengue, but there is a lot of work in another career coming. That is important that our faculty, not only informatics, is interested in having a good relation with you in order to have a better living together in this world. That's bien sus que cambien. Yeah.
If some of you want to go back, you receive all of your